Hello and welcome back. Here are some frequently asked questions. Why does the moon have phases each month? Earth moon is continuously illuminated on one side by the sun. So if you were to fly around the moon in space at any given time of the month, you would always observe that one half is the sunlight side and the other half is the dark side. Over the course of each month, the moon orbits around Earth and our view of the moon changes. And even though the total amount of the moon's surface illuminated by the sun doesn't change, we see a different view of that half-lit, half-dark object each night. That change in view is what we perceive as the moon's phases. Why we always see the same side of the moon? The reason for that is because the moon rotates at the same rate as it orbits our planet, and both takes about a month. When is the best time to see Mars, Saturn, Jupiter, Venus, Mercury? You can easily see with your eyes these 5 planets. The best time to see them depends on whether their orbit is closer to the sun than Earth's or further away. Mercury and Venus are closer to the sun, and they never appear to move too far away on the sky from our local star. So these 2 planets will always be seen near sunrise and sunset. Mercury is closest to the sun, so it always rises or sets soon before or after the sun. Mars, Jupiter, and Saturn orbit the sun further out than Earth does. The best time to observe them is around the time when they are at what is called opposition. This is the time each year when each planet lies directly opposite of the sun from Earth. Near opposition, the planet is visible all night and appears high overhead around midnight. What is the brightest star? The brightest star in our skies, or the star that appears brightest to us from Earth, is Sirius. In terms of absolute brightness, it's around 25 times brighter than the sun. Sirius is located about 9 light years away. Sirius is a very bright star, but it is only the brightest one in our sky because it is relatively close by in cosmic terms. It is not known what is the absolute brightest star in the universe, but one of the brightest known stars is called R136A1. It is about 6 million times brighter than the sun, and it is located about 160,000 light years away. What is the brightest planet? Venus is the brightest of the planets seen from our planet Earth. After the sun and the moon, Venus is the next brightest object in our solar system. Jupiter is generally the brightest of the remaining planets. The brightness of the planets varies as both they and Earth orbit the sun, moving closer and further away from each other. This is true for Venus as well. What are Lagrange points? Lagrange points are positions in space where the gravitational forces of a two-body system like the sun and our planet Earth produce enhanced regions of attraction and repulsion. These can be used by spacecraft as parking spots in space to remain in a fixed position with minimal fuel consumption. There are 5 special points where a small mass can orbit in a constant pattern with 2 larger masses. The Lagrange points are positions where the gravitational pull of 2 large masses precisely equals the centripetal force required for a small object to move with them. This mathematical problem, known as the general 3-body problem, was considered by Italian-French mathematician Joseph-Louis Lagrange in his prize-winning paper Essai sur le problème des 3 corps in 1772. The L2 point of the Earth-Sun system is home of the James Webb Space Telescope. L2 is ideal for astronomy because a spacecraft is close enough to readily communicate with Earth, can keep Sun, Earth, and Moon behind the spacecraft for solar power, and provides a clear view of deep space for our telescopes. How much will daylight change during a total solar eclipse? In the path of totality, where the moon completely covers the sun, the sky will become dark as if it were dawn or dusk. For those who only experience a partial solar eclipse, the sky will appear slightly darker than it was before the eclipse, depending on how much the moon blocks the sun in their location. Why is forecasting space weather important? As society's reliance on technological systems grows, so does our vulnerability to space weather. The ultimate goal in studying space weather is an ability to foretell events and conditions on the Sun and in near-Earth space that will produce potentially harmful societal and economic effects, and to do this adequately far in advance and with sufficient accuracy to allow preventive or mitigating actions to be taken. Here is a great question. What is space and where is space? This may seem like a simple question, but may be more complicated than you think. Although most people are generally in agreement that space begins when Earth's atmospheres end, where exactly that is depends on who you ask. A common definition of space is known as the Kármán line, an imaginary boundary at 100 kilometers or 62 miles above mean sea level. In theory, once this 100-kilometer line is crossed, the atmosphere becomes too thin to provide enough lift for conventional aircraft to maintain flight. At this altitude, a conventional plane would need to reach orbital velocity or risk falling back to Earth. The US military and NASA define space differently. According to them, space starts 12 miles below the Kármán line at 50 miles above Earth's surface. Pilots, mission specialists, and civilians who cross this boundary are officially deemed astronauts. For example, the International Space Station is orbiting between 205 to 270 miles up. Space is an almost perfect vacuum, nearly void of matter and with extremely low pressure. In space, sound doesn't carry because there are not molecules close enough together to transmit sound between them. No one knows exactly how big is space. It is difficult to determine because of what we can see in our detectors. We measure long distances in space in light years, representing the distance it takes for light to travel in 1 year, roughly 5.8 trillion miles or 9.3 trillion kilometers. From the light that is visible in our telescope, we have charts of galaxies reaching almost as far back as the Big Bang, which is thought to have started our universe about 13.8 billion years ago. This means we can see into space at a distance of almost 13.8 billion light years. But the universe continues to expand, making measuring space even more challenging. Additionally, astronomers are not totally sure if our universe is the only one that exists. This means that space could be a whole lot bigger than we even think. In fact, the universe as a whole is inundated with what is known as the cosmic microwave background (CMB), which is essentially the leftover radiation from the explosion mostly commonly known as the Big Bang. The CMB is the oldest radiation that our instruments can detect. And there remain two giant mysteries about space, which are dark matter and dark energy. While scientists have provided extensive evidence for the existence of dark matter and dark energy, they are each still poorly understood, as so far scientists cannot directly observe them and can only observe their effects. However, while dark matter does not emit light or energy and cannot therefore be directly observed, scientists have found overwhelming evidence that it makes up the vast majority of the matter in the cosmos. Dark energy is a mysterious and unknown force or entity that scientists think is responsible for the universe's ongoing expansion. Smaller black holes can form from the gravitational collapse of a gigantic star, which forms a singularity from which nothing can escape, not even light. No one is quite sure what lies within a black hole or what would happen to a person or object who fell into it, but research is ongoing. An example is gravitational waves or ripples in space-time that come from interactions between black holes. This was first predicted by Albert Einstein when he showed that time and space are linked. Time speeds up or slows down when space is distorted. In 2017, the Laser Interferometer Gravitational Wave Observatory LIGO scientific collaboration announced that 3 black hole interaction was detected through gravitational waves. This could help scientists learn how black holes of a certain size are born and later merge into new black holes. Stars like our own sun are immense balls of gas that produce their own radiation. They can range from red supergiants to cooling white dwarfs that are the leftovers of supernovas or star explosions that occur when a big one runs out of gas to burn. Planets are objects whose definition came under scrutiny in 2006 when astronomers were debating whether Pluto could be considered a planet or not. Pluto and similar small objects are considered dwarf planets, although not everyone agrees with the designation. Exoplanets are planets outside the solar system. Essentially, astronomers understand it to mean objects that behave like planets in our neighborhood. The first such exoplanet was found in 1992, and since that time, thousands of exoplanets have been confirmed. Asteroids are rocks that are not quite big enough to be dwarf planets. Most asteroids are concentrated in a belt between the planets of Mars and Jupiter, but there are also many asteroids that follow behind or ahead of planets or can even cross in a planet's path. In our solar system, comets, sometimes called dirty snowballs, are objects believed to originate from a vast collection of icy bodies called the Oort cloud. As a comet approaches the sun, the heat of our star causes ices to melt and stream away from the comet. Among the biggest cosmic structures we can see are galaxies, which essentially are vast collections of stars. Our own galaxy is called the Milky Way, and it is considered a spiral galaxy. There are several types of galaxies, ranging from spiral to elliptical to irregular, and they can change as they come close to other objects or as stars within them age. Often galaxies have supermassive black holes embedded in the center of their galaxies, which are only visible through the radiation that each black hole emanates, as well as through its gravitational interactions with other objects. Large groups of galaxies can form in clusters that are grouped as large as hundreds or thousands of galaxies bound together by gravity. Scientists consider these the largest structures in the universe. Alright guys, if you made it so far in this course, congratulations! Give yourself a hug and a big pat on the back. Well done. You have learned great skill for life about our solar system, space, and the universe. And to quote Albert Einstein, quote, "Education is not the learning of many facts, but the training of the mind to think." Thank you so much for watching, and have a wonderful and a great day.